This problem is asking for the local maximum in quadrant 4 closest to the origin. In some of my versions of Canvas, there is a misprint and it asks for quadrant 2, but there are no local maxima in quadrant 2, so it's not technically a valid question. It was supposed to say quadrant 4. That in mind, let's get started. I thought if we were going to graph this function, we would best be served by starting just remembering what the cosecant graph looks like. The cosecant graph has infinitely many U-shaped things, for lack of a better word, with vertical asymptotes at multiples of pi and local maximum and minimum values of 1 and -1. That's the cosecant graph, and for most people this is just pure memory. Now, we want to know what 1 plus 2 times the cosecant looks like. To that end, let's start by just analyzing the transformation of multiplying the function by 2. Whenever we multiply a function by a number bigger than 1, we get a vertical stretch. Rather than redrawing the entire graph, I'm just going to rescale my y-axis, changing those local maximum and minimum points to 2 and -2, thereby stretching the graph without physically having to redraw it. Now, that's what 2 cosecant x looks like. What if we were to add 1 to that, which is really what the question is asking? Well, I decided not to redraw the entire graph by adding 1, but just to mentally track, okay, adding 1 to this function would shift every point 1 space up. Now, if it's going to shift every point 1 space up, in particular, it's going to shift this local maximum 1 space up. And if that shifts up 1 space, this will be its new location. Of course, the entire graph is going to shift, but I'm focusing particularly on that point because, notice the question at the top, they're asking me for the local maximum closest to the origin, and that would be, at least in quadrant 4, that would be the local maximum closest to the origin. So imagine the entire graph shifting up 1 space, not just a single point, of course. And once that shifts up 1 space, it's easy to do some basic algebra and find out what the coordinates are. And now I know that local maximum closest to the origin in quadrant 4. And that completes this question.